regression and correlation. We are still doing probability, but probability based on statistics, based on info found. What is correlation? It is a measure of the association or the relation between two sets of numerical values. Right, so what do we mean by that? Well, you have often heard studies have been done that shows smoking causes lung cancer. Studies show that drinking alcohol during pregnancy causes brain damage in the baby. All of these things are a relation between one thing and another thing, between two sets of info. The numerical values will then be actually from studies done. So that's your statistics part, the experiments that you've done. So we're going to do an example where we say a number of students were followed, and we watched how long, or asked them how many hours did they study for a particular test, and then we looked at the results they got. So if we put the info here, student name, just to show they are different students, time they spent studying in hours, marks they received in percentage. And the names are irrelevant, it's just to indicate that it was a lot of different students. So I'm just going to call them A, B, C, D. And we're going to say this was how each one reported how many hours he studied for this test. And this was the test results, the marks they got for their tests. So what we're going to do now is we're going to draw a scatter diagram or a scatter plot. What a scatter plot is you take the actual results that you got and you compare them. So obviously the student names are completely irrelevant. What is my independent variable? My X is the hours studied. Remember again, accurate, right? Use your ruler, mark off exactly to scale. Otherwise your plot has absolutely no meaning. Now what you can do, I see my lowest mark was 30%. So instead of, I want to start 30, 40, 50, 60, 70, 80, but you can see this bottom part is not to scale. So then I put a little zigzag there to say, okay, this part wasn't to scale, but from now everyone is going to go up in 10%. So if your numbers start high and you don't want a whole long piece here at the bottom, then you can do that. So this is marks in percentage. Now you plot each one exactly. The guy who studied for 2 hours got 60%. I like to put a little cross, it's clearer than a dot. So where 2 and 60 come together, the one who studied for 5 hours got 80%, 1 hour got 30%, 4 hours got 70%. So that is my scatter plot. It's my actual information. Please note it is not a line graph. So you don't join these little crosses and make a zigzag type of line. What you do want to know is, do these points, and remember generally you will have a lot more than just 4, do they seem to make a straight line, not a zigzag line, one big straight line? So correlation does a straight line closely or maybe just roughly fit the data? That's what we want to figure out. Okay. In part 2 we're going to look at how to actually calculate it. Here I'm just going to have a look and say, well, I could roughly, and remember this is just roughly. This is not what we call my line of best fit. This is just roughly. They do sort of roughly lie around, clustered around a straight line that is increasing. So even though I don't know the numbers yet, I do know that this one is a positive correlation because it's increasing. And what that tells me is if I study harder, I do seem to be able to expect a better exam mark. I do get more marks, right? So let's just have a look generally at correlation. So a positive correlation, your little crosses would almost never fit an exact straight line, but they do seem to form an increasing straight line. And how roughly or closely they are is going to come in the actual number value of the correlation, which we're going to look at a bit in the next section or in part 2. So a negative correlation would be if they do seem to, you can get a little one that's completely outside, but they seem to make a decreasing line. So maybe my example here would be more play, less marks. So then the x-axis will be the number of hours that I played. And then the y-axis would be the marks. So if I played a lot of hours instead of studying, I got less marks. That's a negative correlation. You can also get no correlation. In other words, you do a study and you find, well, actually these things don't have any relationship to each other. Then they would just not at all make any kind of line possible. They would just be scattered all over. What would be an example if we had to compare somebody's shoe size to his test results? And you can think your shoe size has absolutely no correspondence to what you will get for your test. So if you did a study like that, you would say there is no correlation. Your points would not at all be even close to a straight line in any direction.